All right, this is a video to help you finish up your motion project. This video is about steps F and G, about drawing the number line and the sketch and the motion map. If you haven't gotten up to steps F and G, you should probably finish those before you come into the classroom. This is for those last steps. It's hard to do these steps without making your graph already, but we'll go from there. So if you check out my example, this is essentially what we're talking about doing here. And this is a particularly difficult thing to do right. It may look simple, but it's not super simple. We need to focus on the things that make it challenging. So as a part of steps F and G, I'm giving you a few details about how to think about this. If you want to write this down, you can. You don't have to write it down. You can just use it as a reference. Step 1. You want to draw a number line that fits your situation, that matches the 0 reference point and positive direction that you chose. On my example, I was working with a video where I chose the hoop as the reference frame. So I drew a 0 point here, and I drew a positive direction to the right because that's the direction that I chose as positive in my video. Other people, for example, had graphs that looked like this. Like this is for data that had to do with, I think, a buggy that's moving back and forth. And a lot of those videos had the 0 point on the right and the positive direction was pointed to the left. So that's going to be different. You need to make your number line in a way that's consistent for your video. One thing I'll mention about this is the scale needs to be constant. So just like a consistent scale on a graph, your number line has a consistent scale. Notice I went 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you don't have this blue lab sheet paper at home, or you don't have graph paper at home, you can still do the work. Do not let the lack of a piece of paper keep you from doing the work. You can do this work on a white piece of paper if you need to. And you figure out some way to make your scale pretty consistent. So number line is the first step. Second step, you want to use CVM9 and draw a dot on your number line at the position for every clock reading. If you took more than 15 points, you can do every other clock reading, but most of you have around between 10 and 15 points. These dots need to be consistent for your data. So what we're talking about is basically this. We've got our number line already. We've got our data table. And your question would be, all right, what's the t equals 0 point? Where is it on the graph? We would put a dot at t equals 0. Don't worry about the arrows right now, just the dot. Then we say, what's the position at t equals 1 seconds? It's 150 centimeters, so we put a dot on the motion map for that clock reading and so on. Notice I've done that here. T equals 0. I said it was a position of 2.3 centimeters, so I put it at that position on my number line. At t equals 0.5, it hadn't changed, so I stacked up another dot here to show it hasn't moved. And then if we even continue all the way out to, say, t equals 5 seconds, t equals 5 seconds is at 16 centimeters on my number line. All of these dots, or at least half of these dots, should have a label saying like this is a clock reading of 5 seconds, 4.5 seconds. After t equals 0 seconds, you can just write the actual number. You don't need t equals in front of it. But that's the next step. Draw the dots. Again, you are not making arrows yet. You are making those later on. But you do need to make this motion map consistent. The dots have to be matching up with the dots in your data table and the actual positions in your graph. Next thing, step 3. Draw a picture to show the position of the objects at each moment you thought was special. Again, these pictures have to be consistent. So check this out. On my graph, on my example, I chose moment C to be 4 seconds and the clock reading, the position is around 11 centimeters. So I can check down here, I drew my picture for moment C above the dot that says 4.0 seconds, and I know that the position is at around 11 meters. So my picture actually matches up. I can see where this guy actually is at moment C. Or moment A, which you could call the initial position. I can see that this guy's at 2.3 centimeters on the position axis, 2.3 centimeters in the actual table, and I drew the picture for moment A right above the dot for moment A in the motion map at a position of 2.3. All of that needs to be consistent if you're doing this carefully. It doesn't have to be exactly, but it's got to be close enough that I can see that you're thinking about it. The last step that you're going to do here, after you draw the pictures and everything, and after you make little labels, the last step, I forgot to write here, step 4, is to draw arrows sticking out of the position dots. Almost to the next dot. These arrows are what we see here. Arrows sticking out of the dot, almost reaching the next dot. They're what we see here. Arrows sticking out of the dot, almost reaching the next dot. And they allow us to see how fast the thing is moving. So we can tell this guy's speeding up because the arrows are getting longer and longer and longer. Then he's moving at a constant speed. The arrows are the same length. This idea of a motion map that is like making the dots first and then filling in the arrows between the dots, that's a big idea, and we need to spend more time with motion maps. But CVM9 is telling you how a motion map works. And the motion map for this might be kind of complicated. You may notice that you have to go up to a second level, for example. If this thing changes direction, you would need to keep that organized somehow. Making those decisions is up to you, but I would suggest making your dots nice and big so we can see the position and make sure the arrow actually sticks out of the dot. Like I said, tomorrow we'll have a little bit of time to work on this, but you should have basically all the checklist items done, including trying to do your velocity graph so that you can actually come into class and finish it up, get some answers to questions if you have it, and make it perfect. Just in case you need it, this checklist and the rubrics on the back are available on the class website on the motion projects page. This sample motion project work is also available on that page, so look carefully there to find those resources.